Welcome to this DEPSIS Cover webinar. My name is Omid. I'm responsible of R&D in DEPSIS.
This is Mohtar Bozorg from University of Applied Sciences in Yverdon.
Today's discussion is actually organized in 3 parts. The first part is about the Grid Data Digger project. Second part is about the value of big data analytics projects for grid operation. And the third part is about research questions beyond the scope of Grid Data Digger projects. And so here you have in the bottom of the screen the Q&A part. You can put your questions, and if it's something very urgent, you can also raise your hand if needed. We can also bring you to the conversation, but the usual one is to put your question in the Q&A section, and we can answer your question throughout the presentation. You don't need to wait to the end. All right, so I think a good number of people already joined, so let's start. So we start with part 1. I'm gonna use a few charts for better presentation of the topic of the event. All right, so we start with the presentation of Grid Data Digger project. So the first thing that we're going to start is the question of why we need to do what was the need to do the Grid Data Digger project. So the real need, the main driver was actually the acceleration of energy digitalization in the distribution grids, in the operation of the grid and the process of operation in the grid, which was because of the needs and the targets that should be reached in the energy transition, in the emission reduction, and the increase of renewables and electrification of energy consumptions. So these drivers has resulted to increase of grid monitoring infrastructure and more grid data being available. And so what should be done with all this data? How the DSOs can use this data to improve the operation, to improve the process of the operation, and improve the decision makings in the existing environment. So in the Grid Data Digger project, the main objective is to valorize the available data for the grid grid operation, especially by providing suggestions and recommendations about the optimal and secure grid operation, by using big data analytics, advanced analytics that are running on a big data platform. So this was the core of the main reason and what we wanted to do, the question and the target and the objective of the project. And of course, this was a project that we started in June 2019, and the project lasted for 2 years with the support of InnoSuisse. So DEPSIS was the main implementation partner, and University of Yverdon was the research partner participant.
Speaking of us, I mean, University of Applied Sciences in Yverdon. So as Omid truly said, the project is a multidisciplinary project. When you need to have expertise on the electrical grid side and power system, classical power system analysis, and also needs tools to be developed and to be implemented by people who are expert in artificial intelligence, in machine learning, development of the algorithms, and also people who are experts in data science in general. So treatment of data, processing of data, storing of data, and to provide tools to run such algorithms. So this is why 2 institutes of University of Applied Sciences in Yverdon are strongly involved in the project, Institute of Energy and Electrical Systems, where Mauro Carpita and myself were leading the activities, and Institute of Information and Communication Technologies, where Professor Nassan Fatemi and Carlos Pena were leading the activities. Speaking of this multidisciplinary nature of the project. So let's go a bit more into the details of the project aims. So as you mentioned, the starting point is that now we have, and we are going to have more and more data available, and by data we mean monitoring data like voltages, current measurements, power measurements at different levels of distribution grids, at medium voltage, low voltage, at transformer level. So the first step to do, to move from, let's say, this raw data into more valuable information is achieved through some descriptive algorithms and some descriptive analytics. So first of all, what we have done is we wanted to see a history of data, classify this data into, for instance, what are the differences between different nodes, different subgrids in terms of penetration of photovoltaic generation, in terms of type of loads, whether we have nodes with more industrial or residential loads, what are the correlations temporally or especially between these measurement data. So the first level of adding value to this data is to better describe them. Second level is through some diagnostic analytics where, for instance, we want to identify the events like over voltages, under voltages, or no voltages when they happen in the grid. And to identify them as soon as they happen. And also we have complex events identification where we deal with simultaneous events, chain of events coming at the same time, and how to classify and cluster them. Then the next step would be how to predict such events. So how to, few hours ahead, how to say, in 4 hours ahead, we will have over voltages, where it happens, how big is this over voltages, or under voltage, or overloading, or currents. And finally, ultimately, what are the preventive actions we can do to avoid such grid violation events like over voltage or overloading of transformers. So this is the path that we went through in the whole Grid Data Digger project. So just as an example, we have, for instance, here, just an illustration of the platform that is developed for complex event identifications, where the first idea is when we have over voltages or under voltages, most of the cases, these are related or caused by one single root cause, maybe an overconsumption or an overproduction in a specific node of the grid. So first step of this kind of complex event identification approaches is to regroup the events, simultaneous events together, and instead of giving another like hundreds of alarms of overvoltage to the distribution operator and overwhelming him with these alarms, group them together, have a chain of them which are related to each other, and then next step would be what is the root cause of one of these chain of events. So to say, okay, this specific node, because of overproduction or overconsumption on this node, we had this chain of over voltages or under voltages happened in the network. Next slide, Omid, please. Or this is an example again of prediction. So like few hours ahead, we wanted to see the over voltages happening in the network. So the algorithm is quite efficient, and 85% we managed to validate it based on real data. We managed to predict over voltages. Why 4 hours ahead, for instance? Because to have enough time to do some preventive action. Another example is also to the type of algorithm that we have developed in Grid Data Digger is to do prediction of loads and currents of lines at the nodal level or at the transformer level as well. Again, with high precision.
All right, so these kind of interesting algorithms that Mukhtar talked about, they should be shown and demonstrated in certain platforms. That's why in the project, we also developed a demonstration environment that we can visualize the results and outcomes of the projects. Example of power forecasting on the top, and example of complex event identification, you can see it in the bottom. But all of these interesting algorithms and advanced analytics, either the descriptive, the diagnostic, predictive, and the preventive, and this visualization platform and interface, they are based on, they're developed on top of a suitable architecture of big data. What do I mean by that? Because in the right-hand side of this slide, you see the demonstration part, the demo and visualization, but in the left-hand side, you have all the measurements coming from the grid. So we are, in this project, we really want to use only the grid measurements and try to make the maximum out of them. So these measurement data, they have to go through a proper data ingestion mechanisms, and then they have to be fed to different stream or batch processing mechanisms, which makes them ready and prepared for all kind of analytics that may use all kind of artificial intelligence and machine learning algorithms. So that's one of the key factors and important outcomes of the of a suite of a successful big data project. And good analytics project, it should be really built on top of such a platform. So I think we reached to the end of the first part of the presentation, which was about the presentation of the Grid Data Digger project. Now we're going to move to the side of the value of such big data analytics projects for grid operation. I think Mukhtar, you take the.
Yes. So for me, let's say the ultimate value is that these tools helps integration of renewables, integration of more and more electrified devices into the distribution networks. But why this is important? Because in the energy transition context, the more, let's say, solid solution is to electrify as much as possible different consumption sectors, so transportation through electrical vehicles, buildings through heat pumps, through the conversion of electricity into heat. So these sectors, let's say, should be more and more electrified, and the source of electricity would be renewables, photovoltaics, at the distribution grid, at the distribution level, for instance, in Switzerland. But let's say all these new devices, they come with converters. They are power electronic devices connected to the traditional distribution grid. So the integration is not that easy. I mean, so you need to monitor carefully the flow of power. You need to monitor events like over voltages, under voltages, and to do this, you need this kind of tools. You need, first of all, to have this monitoring data available, but then also you need to be able to process, because let's say in few years, when you have hundreds of thousands of these devices, electric vehicle charging stations, photovoltaics at the small distribution grid level, then you need to process the data, the measurements coming from every node, and you need to react and to prevent any grid operation violations, for instance. So let's say very direct use of the results of the project, but also these can be used in other sectors, like of the distribution grid businesses. So for planning reinforcement of the grid, what are the needs for maintenance as well, and also why not to use this monitoring data for having a more transparent, or let's say a transparent realization of local markets, exchange of energy and power between these distributed photovoltaics, for instance, and also the consumer. So these are let's say, the main added value that I see from very direct values, like operation, avoid operational limit violations, which we expect to have more and more by increasing the penetration of photovoltaic electrical vehicles, heat pumps, and so on. And then later on to use this monitoring data for realizing local markets, or let's say environments for the exchange of power and services between these distributed resources.
In fact, that in addition to the these advantages that this kind of project has for energy transition plans and objectives, we can really think about other benefits that it might have for institutes. I mean, for example, for research institutes, they can really work on solving the problems of today and future. So there is a kind of need for this to solve and address these kind of problems. And at the same time, for the main implementation partners, technology funders like DEPSIS, it's also it's an opportunity to make the value proposition a little bit more complete, because in addition to what we have right now as an edge computing, real-time grid monitoring with some analytics, like extending it and going to additional and more advanced analytics, targeting really the day-to-day and the needs of the DSOs, and trying to address and solve some of their problems in a daily basis. Also, I think since we touched the word DSO a lot in this presentation, I think at the end they are the main need owner of such kind of projects. They definitely need the outcome of these kind of projects at the end ultimately should be used by them to help them to improve if there is any need to address some challenges in their existing businesses, or accelerate certain tasks, or improve certain decision-making processes. So all in all, these kind of big data and big data analytics projects based on just monitoring data, they can be a good, very valuable things to improve in general the grid operation aspect. All right. Mokhtar, do you have some additional points to add here?
Oh, I just really forgot. I was just reading the chat, and I think there is an issue with my microphone. I don't know if you hear me well now, or
yeah, it's relatively good. Yes.
Okay.
It should be fine. Yes, since you are going also to the last 10 minutes and the third part of the presentation and discussion, I can go to the side of, like, we talked in the first part about the Data Digger project, the second part about the value of these kind of projects. But of course, what we did in the Data Digger project does not solve all the problems of the field. So what are the kind of challenges or research questions that remains after Grid Data Digger projects for future?
There are many, actually. There are many, and this is somehow an open field for exploration. To me, one of the very important aspects is the accessibility and also trustability of available data. So let's say we put on the hat of a distribution system operator. So you have many different sources of input data. You have not just data coming from grid monitoring systems like the one of DEPSIS, but you have, for instance, smart meters data on the clients, on the customer side, which provide energy profiles. You have also at the transformers or different component level, you have also some, let's say, component level monitoring. So you have different sources of data. So one big question is how to let's say make an agreement between these different sources of data, because these data are not always in agreement. If, for instance, we take also static information like grid models, the topology of the networks, which are like informations that are from time to time the distribution system operators are updating those informations and topologies. So the very interesting question to address is how to make these different sources of data work together, so let's say combine them together, take advantage of synergies that you can have from these different sources of data to create somehow one single trustable state of the network, or let's say source of trust to do game analytics, to do simulation, to use it in your decision making process. So this is one that for me big open question to address and to work on. This is on, let's say, on the input side, but on the output side as well. So let's say you develop some applications, predictions, like the complex events that we work on it in this project, but how you can find a good way to guarantee interoperability of these outputs with other, let's say, business or activities or grid operation activities of a distribution system operator. So how different units, different people with different objectives inside a distribution grid operator could use the outcome of, let's say, one specific project or one specific application to make it connected to the rest of their business. So this is also an interesting question to work on.
Indeed, this aspect of multi-usage of the data and not thinking only as the data for one specific objective, that's an interesting and important point. The moment that this trustable, accessible, and federated data source is generated, so it should be taught about methods and methodologies to use this data for any kind of application that it can serve. Also, as you mentioned, the interaction between the different algorithms and applications, they should be also something taught, like not having standalone and islanded tools and applications. Everything should be linked. They should exchange information. That really increase the value of such a data environment, and it helps to increase the value extraction from this kind of big data or analytics projects. I just remind you that there is a Q&A bottom below the screen that you can add, put your questions there. So feel free to add your questions there. And so far, I don't see any question. If not, I can switch to I think one aspect, Mukhtar, that is quite interesting and important, especially when we go to the side of the real-time data, is the aspect of the control, because there the value of the real-time data is become more and more important. And this is, let's say, something that in the Grid Data Decade project we touched a little bit by looking at the need to do control by predictive and then preventive. But then when we go to the real execution of control action, that is something outside.
Yes, I mean, it was, let's say, deliberately we put it outside the scope of the project. But there was a reason behind this, and this is a matter of who owns the controllable devices, who has the right to act, to execute them. And well, there are, of course, like legal, financial layer, and there could be different type of business models. But let's say if we don't care about this, and let's say this is solved, then a very interesting challenge is how to communicate with these controllable devices. At the distribution grid level, we have a large number of small-scale devices. So how to communicate with them, how to send the signals to them in real time, this would be a challenge. This would be a challenge at the technology level. This would be a challenge, communication. And this would be also a challenge on the optimization and control side as well, because we have, let's say, if you want to go through some centralized solutions, so you need enormous computation effort. If we go through distributed one, then who does what and how to coordinate? So this is not this is an open question. Still, there are few. If we stay optimistic, there are very few projects trying to address these aspects. But these are definitely this is the future to go.
Absolutely. And so we talked about the Grid Data Digger projects. Of course, the project is finished, but its implementation is in progress. So we are adding more and more of the outcomes of this project into DEPSIS products. And we will also continue with the future industries projects or other kind of projects to go to the to discover next steps and next objectives or next research question that we discussed here. Right now, we just received a question. I'm gonna read
which is very interesting and relevant.
So I read the question, and Mokhtar, you take if you want to start to address the question. With increasing penetration of monitoring devices, could there be scalability issue of such grid data aggregation and in the training of the grid models? Did you see some limitations in your research?
Yes. So scalability is really important here, and this is actually why we do need these big data platforms. So we have distributed computation systems. So we relied on a Spark technology. So instead of just running the models for training on a single machine using Python, for instance. So we first did this in a small scale, but then run these algorithms also and transform these algorithms into, for instance, Spark, and then run them to train models. And then what are the limitations? So we tried up to thousands of nodes for distribution grids with training period of few months to more than 1 year. So in terms of the scalability, I would say for this kind of application, so like prediction of events or prediction of power profiles in distribution grids, like the big data platform that we propose or we develop in these projects are usable. Then if we are thinking of larger scales, like tens of thousands or 100,000s of nodes, we have not run the algorithms themselves, but what we have done was to do feasibility tests on the data ingestion and the storage side. So 10,000 or more devices sending measurement data at the same time, the platform is capable of handling that.
Thank you for the question and for the answer. Since we're getting close to the end of 30 minutes, I just take the occasion to show you a few points or let's say concluding remarks of today's meeting and discussion. So the first point that I want to highlight here is that the real-time grid monitoring data, they are a very valuable source to generate insight for the grid operation, and that's one of the things that DSOs they can really use and benefit from. Second point is that the architecture, a suitable architecture for big data is necessary, as Mokhtar and the last question highlighted again, to run this kind of any kind of artificial intelligence or machine learning analytical methods. And last thing from the Grid Data Digger project, in this project we tried to advance, we developed advanced analytical application, descriptive, diagnostic, predictive, and preventive on a big data platform, only using grid monitoring data. We didn't use any grid structure, grid model information. We just use the grid monitoring data to support DSOs in their operation basis. So the objective of the project was also only the operation, not planning or asset management or that stuff. So with this, I want to thank you all for your
Maybe a very last word from my side. So you can reach Pepsys to also to try the platform, the demonstration platform, to see how it works, how it looks like working with these applications. And also on the, let's say, research side, you can contact us in Institute of Energy and Electrical Systems of School of Management and Engineering of Canton of Vaud in Yverdon.
Thank you very much, and I hope you enjoyed the coffee. Bye-bye.
Bye.